Oh, hey!
Hello.
Good to see you.
Oh, thanks. You too.
Oh, thanks. So, the other day we talked about multiplying rational expressions, but guess what? We can also divide!
Whoa!
Alrighty. So, just like we started off with multiplication, we gave some examples of rational numbers and how we multiply those. We're going to also do the same thing and give us examples of how we divide rational numbers in this case. So when we divide fractions or rational numbers, what we've been used to is that we actually take the second number, that second rational number, we take the reciprocal and then we multiply instead. So we flip and multiply is what I like to say. And so we take three halves and then we multiply by 11 over 7. And you know what? Instead of this X sign for multiplication, I'm going to put the dot because eventually when we get into with the variables and the rational expressions, I don't want to get confused. So we have 3 halves times 11 sevenths. And then we multiply as normal. Numerator by numerator, denominator by denominator. So 3 times 11 gives me 33. And 2 times 7 gives me 14. Alrighty. Same thing goes for the next one here. So instead of dividing, how we do that is we flip and we multiply. So we take the second term, we get the reciprocal, which is 15 halves. What we might notice here is that we have some common factors in our numerator and our denominator. Ooh, yeah. 15 and 5 both have the common factor of 5. So this guy becomes 1 because 5 goes into 5 once. This guy becomes 3 because 5 goes into 15 3 times. And the 8 and 2 also share some common factors. They both have a 2 in common. 2 goes into 2 once. 2 goes into 8 4 times. And if we continue on with our multiplication here, and we go numerator by numerator, we get 4 times 3, which is 12. Denominator by denominator, 1 times 1, which is 1. But we don't have to write the over 1 there, because that is an implied piece. So we end up with 12. All right. So when we are dividing rational numbers, we just multiply by the reciprocal. Similarly to when we divide rational expressions, we're also going to multiply by the reciprocal. The one thing that we need to keep in mind is that we will still have non-permissible values. When we are looking for non-permissible values exist in any piece of the denominator at any given point of your work. So, for the first one, for our first factor there, we have non-permissible not what I was trying to say. For multiplication, when we're looking at our factors, we look at the non-permissible values of both denominators. We do the same when we're looking at non-permissible values of quotients, but we're also going to be looking at the non-permissible values of the numerator of our second value, because eventually that becomes in the denominator. So what we're going to do is we're going to take a look at that to see what actually happens here, and we're going to be looking at this statement. So, first question, we have x plus 3 divided by x minus 1 divided by x plus 1 over x minus 4.
Mouthful.
Yeah, it really is. When we are doing that, when we're doing this division statement, we are going to multiply by the reciprocal. So here, x plus 3 over x minus 1 stays the same. But now instead of dividing, we are going to multiply, and then we're going to take the reciprocal of the second expression. So x minus 4 over x plus 1. Okay, so we flipped this second expression. The denominator became the numerator became the denominator, and now we're multiplying instead of dividing. Okay. We are going to look at these guys here and say, is there any common factors in our numerator and our denominator that we could potentially eliminate? And the answer is going to be no, because there's an x plus 3 on the top, but not an x plus 3 on the bottom. And same with all the other values there. So what we're going to do is we're going to straight up just go ahead and multiply. So our numerators becomes x plus 3 times x minus 4. And our denominator becomes x minus 1 and x plus 1. Now, we've done all of the division that we've got to do by multiplying the reciprocal. What we haven't done yet is acknowledge any of our non-permissible values. And our non-permissible values are going to be, the way that we're going to find those, we're going to look at the denominator at every single point of this whole entire division journey. So, when we look here, oh, that's way too big for me there. X minus 1, we would have a non-permissible value when x is plus 1. We also have the non-permissible value here when x is minus 1. So let me say plus or minus 1. But that's not all. We also have this x minus 4 in the bottom at one point of our division process. So we also have to acknowledge that non-permissible. So that is also going to be x cannot equal to positive 4. So this is going to be our final answer here, this whole entire thing. But what you'll notice is that when we're looking at non-permissible values and we're doing it in a division statement, we are looking at the denominator of both of our original expressions, but also the numerator of our second expression, because that ends up flipping and becoming on the bottom. So we've got a lot of non-permissible values here, more so than what we would have had in multiplication because of that flip. Okay. Alrighty. We're going to do another example. It's going to be great. Life is good. Whoop, whoop. And we're going to crush it because, honestly, we're pretty awesome. We're going to start by going ahead and we are going to flip and multiply. So our numerator becomes our denominator becomes our numerator in the second term. So I get x minus 2 over x plus 3. That stays the same. We get a multiplication of our second, which is 2 minus x. And x minus 5. What we might... Oh, just kidding. I didn't flip that at all. I just copied it as is. Silly, silly me. So x minus 5 and 2 minus x. Now we've got the reciprocal.
Honestly, it's a common error.
Yeah.
Yeah.
Yeah, especially if you're running or zooming through things.
Yeah.
What you might notice in this denominator here is we have 2 minus x. Usually, we're actually used to things the other way around. We're usually used to seeing factors in which the x comes first. So what I'm going to do is just going to rewrite that so that the x value comes first. And then the constant or the number comes second. I can't just change it and go, okay, well, x plus 2. I can't just go ahead and do that because I have a negative x. I still have the positive 2, so that's fine. But I need to include that negative x when doing that here. What I also might do, because I notice here that I have an x minus 2. I don't know why that's going so large. I'm pressing too hard. That's why. Duh. I have an x minus 2 at the top here. I have a minus x plus 2 at the bottom. They're not quite the same, but I can kind of rewrite things for this bottom guy to make them look more similar, right? There's a GCF that I could pull out here of a negative 1. And so then I could end up with x minus 2. Right? I don't have to write the actual negative 1 in there. I could have just the negative sign. But if I pull out a negative, I will be left with x minus 2. And when I do that, oh, baby, I realize that I have an x minus 2 at the top and an x minus 2 at the bottom. I'm going to put everything in brackets here just so we love life a little bit more. Notice when these cancel out, the x minus 2's cancel out, there's still a negative 1 that exists. That does not get canceled out with it. That is a factor of that multiplication of this whole thing here. Just the x minus 2's cancel out. Alrighty. My numerator, I am left with x minus 5. My denominator, I'm left with x plus 3. And then I still have that negative 1. Because it doesn't totally matter where I put the -1. I could put that top, I could put that bottom. I'm going to put it right smack dab in front of the whole thing. We could go ahead and do that. And I need to state my non-permissible values. Remember that for my non-permissible values, they're the values of my x anywhere along this whole division journey that make my denominator equal to 0. So, because of this guy, I can't have, I'll do a different color. I can't have x is equal to -3. Because of this guy, I can't have x equal to 2. And because of this guy, I can't have x equal to +5. So my final answer is this beautiful simplified expression and these non-permissible values.
Those aren't so bad. Maybe I'll try one. Ah! What is this? It's different. But that's okay, and we'll love it all the same. What we'll probably want to do here is factor. So I'm going to factor. I'm going to take a GCF out of the top here. And that bottom is x plus 2 times x plus 2.
Ooh, perfect for a trinomial.
They're pretty dope. There's a common x here. And this is something. And if you're ever unsure as to whether you factored correctly, just expand it back again. Just redistribute things and see what you get. You should get your original expression back. Right? You are familiar with that concept. All right. Now there's a whole bunch of factory things. What I might consider doing at this point, just as a note to myself, I might just start keeping track of the NPVs. And I can tell that x won't be able to be -2 because of that. And because of this, I can tell that it won't be able to be 3. So let's start keeping track of those. Now, division, I like multiplication. So I'll address that aspect next. This first rational expression stays the same. But if we want multiplication, then the second one has to get the old flippy-do. And I know that flippy-do causes more NPV, so I'm just going to take another look at this new denominator, which was not a denominator before, and account for those NPVs. So I've now got my whole list of what's got to be non-permissible, and I can just readdress it at the very end. Oop, blah. Now, I can see what I can cancel out here. There's an x here, there's an x there. Got it. There's an x plus 3 on top, there's no x plus 3 on the bottom to get rid of it. An x minus 3 on the top, no x minus 3 on the bottom to get rid of it. An x plus 2 on top, and I can pick one of these to get rid of it. And that's it for eliminations. So for final answer, on top, x plus 3 times x minus 3. On the bottom, x plus 2 times x plus 1. And we are saying that those things are entirely equal, our original division statement, and this resultant rational expression, as long as x is not any of those non-permissible values, which are -2 and 3 and 0 and -1. Ooh, that was fun. I think I shall try another. Math is like chips, you know?
Can't just have one?
I know that's what is that slogan for, like Lay's?
I would argue math isn't like chips because I love math and I don't love chips.
Are you serious right now?
Yeah.
Oh my goodness, Siri, go away. You don't like any kind of chips?
Chocolate? Chocolate chips?
Is that a Lay's brand?
Chippets?
I don't have a joke for that one. So I'm just going to keep doing this math. Don't like chips, eh? But you do like factoring. How do these factors look?
Oh, they are looking good.
Nice. All right. Well, I'm just going to start jotting down some NPVs here. Just because I like to keep track of what I'm doing. So X. It's not permissible for X to be -7 or 2. Or, well, it's -7 again. We need to recycle it. And -1. Okay. And now I'll tackle my flippy-do step. Oops, my equal sign looks
Wonky.
Yeah. So first term stays same. Division becomes multiplication if we flippy-do the second part. That caused a new NPV. This x plus 3 wasn't in a denominator before, but it is now. So that's added to the list. -3, you're on the list. Ooh, where's my crossout color? Found it. These x plus 3s can go somewhere and play. These x plus 7s, see ya. And if these x plus 1s are muchachos, then adios muchachos. Leaving us with x minus 5 and x minus 2. So these are same. As long as x is not equal to anything it's not permissible to be, such as -7 and 2 and -1 and -3. My hand's tired. You want to take over?
Yeah, that looks fun. Can I?
That's literally what I just asked.
Okay, I'll do it.
Great.
All right. So, same process as Mr. Athide was explaining before. We're going to start off by making sure everything's in factored form. So, actually, just if you can, pause the video. Give these next two a go.
Yes.
Because you are super capable and super smart. And then just come on back once you feel like you're ready. And life will be good. We could compare answers maybe. All right. Wicked. We are back and ready to attack. So, I'm going to go ahead and factor this top bit. We have a difference of squares. And then factoring the bottom bit. We get 5 and 3. Okay, and then we have the division. The next guy, we don't have to factor anything at the top because it says factors as it gets. And this guy here, we have x plus 3, x plus 2. And like what Mr. Athide was saying before, it might be useful to start keeping track of some of our NPVs because there's lots going on here. So here, for this guy here, our NPV would be x is equal to 5. It's non-permissible for x to be equal to 5. For this next one, it's non-permissible for x to be -3. For the next one here, same. And for this list one here, it is non-permissible for x to be -2. This 3 is kind of ugly. I'm sorry. Let me rewrite it. Alrighty, now that we're all in factored form, we can do the multiplication of our reciprocal here.
Oh.
Woohoo!
Woohoo.
So we have x plus 2, x minus 2. Our first term stays the same. And then we have the multiplication, and now on top we have x plus 3 and x plus 2. And in our denominator we have x minus 2. And that was not in the denominator before. So we have to account for it in our NPV. So x can't be positive 2. So instead I'm going to put x cannot be positive or negative 2. So x is a non-permissible value when it's positive 2 or negative 2. Ah! My 2! Oh no! Alright. Now we're going to see what we can cross out and eliminate. Well, bye-bye, x minus 2s.
Eliminated.
Goodbye, x plus 3s.
Eliminated.
And that's it. Remember, we can't cancel out these x plus 2s because they're both in the numerator. They have to be one on top, one on the bottom in order to cancel out.
Not eliminated.
So what we've got left in our numerator, we have x plus 2 times x plus 2, but I can write that as x plus 2 squared, right? And then in my denominator, I have x minus 5. Of course, I need to list my NPVs, but luckily I have this handy-dandy list that I have from the beginning, so I'm just going to rewrite those. So, x cannot equal to 5, negative 3, or plus or minus 2. And there we have it. We've got one left! Woohoo! Alrighty, if you did not try this on your own before, try it on your own now. You can do it! You got this! Alrighty. We're gonna kick things off by factoring some stuff. It's gonna be sweet, it's gonna be dope, it's gonna be great. And while I factor, you can also factor.
I'm sorry, I don't understand that dialect.
Oh, it's an ancient mathematicianal language.
Mathematicianal, eh?
Yeah, it sounded dumb when I said it too. Alright.
I'm aware. Chocolate chips.
What?
Chocolate chips.
They're the best kind. For sure. Did you check out my factory? Am I good?
No, I'm thinking about chocolate chips. Are you?
I think so.
I don't remember what the original question was. This looks good.
It looks good. Alright. We did all the factoring. Now, we need to flip and multiply. Because division is hard. So, our first expression stays the same. Nothing happens here. Nothing to see. Nothing to do. But then, the second one, oh, we are going to flip. We are going to multiply. It's going to be great. I realize at this current moment in time, I didn't keep track of my NPVs. Keeping track of them on the side is technically optional because you're going to list them off at the end.
Oh, absolutely.
So if you didn't do it now, you do not have to do it this very moment as long as it's in your final answer. And maybe this time around I'm going to leave it for my final answer just so that we can just take a look at it that way. I don't know. Seems decent. Alrighty. Let's jump to crossing things out. So we have this 2x plus 3 at the top. There's no x plus 3, or there's no 2x plus 3 at the bottom to cancel out, so yikes. X minus 6 at the top. There's also this x minus 6 at the bottom. So we will cancel those out. 2x minus 3 at the top. No 2x minus 3 at the bottom. We have x plus 2 at the top. And we have an x plus 2 at the bottom. So those can cancel out. And that's all we could possibly eliminate. So, in our numerator, we are left with 2x plus 3 times 2x minus 3. We do not have to FOIL them out, but you notice that that numerator would be the factors of a difference of squares. And this is what we are going to be left with. Now, we have to state some NPVs. So, when we're looking at our NPVs, we are going to start from the beginning and then continue all the way through at all of our denominator all the time. So, x minus 6, that would mean that we'd have an NPV of positive 6. So, x cannot equal positive 6. X also can't equal negative 2. X also can equal positive 3/2. This is the same as this guy, so we've already got that NPV out of control. Or under control, not out of control. Silly me. And then these
are
guys
bouncing on the wall.
And then these guys we haven't accounted for yet either. So this first one, x cannot equal 1/3, and this last one here, x can't equal positive 4. So we've got a full list going on. Do-do-do-do-do-boop. Oh, I didn't want purple. I don't know. Let's go. Ooh, lime green!
Oh, wow.
Yeah, that's nice. Alrighty. So that concludes our dividing rational expressions.
Yeah. It's a shame we don't have any practice work.
I know. I guess we'll just have to go straight to our next page and see what's happening.
Whoa!
There is practice. Christmas is saved.
Came out of nowhere.
Oh, man. Thank you, Batman. And there's even answers at the bottom. What a silly goof. All right. So.
Don't look at the answers now. Look at the questions first. Gracious.
Okay, Batman. All right. That's it for today. Take care. Peace out. We miss you. And